I want to start this deep dive by asking you to travel back in time with me. It's roughly 1979.
Okay.
You're a tech enthusiast, maybe a bit of a geek, and you're in your living room in front of the family TV. You've got a computer hooked up, maybe an Apple II, maybe a Commodore PT. You turn it on and you get that familiar, glowing, blocky text.
The era of blinking it.
Exactly. You might spend 3 hours typing in code from a magazine just to get a ball to bounce across the screen, and honestly, it feels like magic.
For about a week, yeah.
Right. And then you hit a wall, you look at the jagged graphics, you listen to the sound, which is just a series of, angry bleeps and bloops, and you realize something pretty depressing.
You realize you're playing with a toy.
It's a toy.
Yeah.
That was the huge frustration of that era, this massive gap. On one side, you had these 8-bit home machines that were sure they were affordable, but so limited.
Incredibly limited. And on the other side, you had the mainframes, the mini computers used by NASA and big universities. Those machines could do amazing things, high-res graphics, real work. But they cost as much as a house.
So you had the toy in the living room and the God machine in the server room, nothing in between.
Exactly. And that is the problem we are tackling today. Because right in the middle of that frustration, a hero emerged. A specific piece of silicon that didn't just bridge that gap, it obliterated it.
The engine for the entire 16-bit and 32-bit boom.
We are talking about the Motorola 68000 family of chips.
I love this topic. We usually talk about companies, Apple, Sega, Atari, but today we're talking about the shared brain that powered them all. This isn't just about a processor. It's about how workstation power finally came home.
It really is. It's the moment the computer switched from being a passive device for, consuming simple games to a creative tool. This chip democratized creativity.
It changed how we make music, how we publish things.
How we write code, everything.
So let's unpack this. The word processor gets thrown around constantly, but to get why the 68000 was such a revelation, we have to look at what came before. What made those 8-bit chips so scrappy?
Well, the processor is the brain, right? It reads instructions, moves data around. The 8-bit chips, like in the Commodore 64, were designed to be cheap. They're like a very small, very efficient courier on a bicycle.
Okay, so they can only carry a tiny package of data at a time.
A tiny package.
Yeah.
So if you want to move a lot of data, like a detailed photo or a sound sample, that little courier has to make 1 million trips back and forth. It's slow.
And the 68000 was not a bicycle.
Not at all. It was a semi-truck. It was designed from the ground up with a completely different philosophy. It was built to look and act like a mini version of those huge office mainframes. A 16-bit powerhouse. And internally, it was actually 32-bit.
Okay, we need to get into the weeds here because the specs are legendary. But let's not get lost in jargon. The notes mention a linear memory model as the killer feature. Why should anyone care about linear memory?
This is where we have to get a little technical, but it's worth it. You have to understand that the other big chip gaining traction at the time, the Intel 86, which ended up in the IBM PC, handled memory in a way called segmentation.
Segmentation? That sounds complicated.
It's a nightmare. For programmers, imagine a library where every bookshelf is in a separate locked room. You get a book from the shelf next to yours. You have to walk out, unlock another door, and walk back in. You could only see a tiny chunk of memory at a time.
So if I'm writing a big program like a video game, I have to constantly be telling the processor to switch rooms just to find my own data.
Constantly. It's mental overhead. It's exhausting. It's like trying to paint a mural while looking at it through a keyhole.
Wow.
The Motorola 68000 looked at that mess and just said, no. They went with a flat linear memory model.
Which means?
No locked doors. It's one giant warehouse. A programmer sees a single continuous block of memory addresses from 0 all the way up to 16 megabytes.
Which in 1980 must have felt like infinite space.
It was an ocean. And because of that clean design, you could focus on the actual application, the game, the drawing tool, not on wrestling with the hardware. That's a huge reason the 68000 became the darling of the creative class. It had this clean instruction set that felt like a fluent language.
And because it was so easy to work with, the hardware manufacturers just jumped on it. The lineup of machines using this chip is basically the Hall of Fame of the 1980s.
It's an incredible list. On one hand, you have the Apple Macintosh in 1984.
The machine that introduced the mouse and Windows to the masses. The Happy Mac.
Right, a serious, clean, user-friendly machine. But then, using the exact same chip, you get the Commodore Amiga in 1987.
Which was kind of the rebellious artist cousin.
The Amiga was a beast. It had these custom chips working alongside the 68,000, allowing for 4,096 colors, multi-channel stereo sound. It was doing video editing in people's basements while PC users were still staring at green text.
And then the musicians show up with the Atari ST.
Ah, the Atari ST. Famous because it had MIDI ports, musical instrument, digital interface built right into the side of the case. It became the standard for electronic music.
I've seen the photos. There's always an Atari ST running the show in those old studios.
Always. And we can't forget the gamers, the Sega Genesis or Mega Drive in '88.
Genesis does what Nintendo?
Exactly. That marketing was all about speed, blast processing, which was really just a fancy way of saying we have Motorola 68,000 and Nintendo doesn't.
It brought the arcade experience home.
It really did. And that's the key point. There was also the Sharp X68000 in Japan, this absolute monster of a machine. The common thread across all these wildly different machines, a Sirius Mac, a Creative Amiga, a Sega console, was that same Motorola brain.
Amazing. But let's move to the so what factor. Specs are great, but what I love is how it changed what people did with computers. We moved from just consuming content to actually creating it.
That is the crucial shift, democratizing creativity. Take gaming first. The 8-bit era, you had blinky graphics. The 68,000 allowed for smooth scrolling, massive sprites, realistic music. People talked about arcade perfect.
Oh, and I remember that pain. You'd see the amazing box art, then you'd turn on the game, and it was a blocky mess. It was a betrayal.
Total betrayal. But with the 68,000, that gap closed. Kids were playing Strider or Golden Axe at home, and it looked just like the machine at the arcade. It changed the expectation of what home entertainment could be.
And it wasn't just visual, right? It was auditory. We mentioned the Atari ST and MIDI. There's this great anecdote in our research, the bedroom studio.
This is a perfect example of the so what. In 1989, imagine a teenager in the UK. He's got no money for a professional recording studio.
Which would cost hundreds an hour.
Right. But he has an Atari ST. He hooks up a synthesizer, uses the built-in software, and records a synth pop track right there in his bedroom.
And this isn't just a hobby project.
No. He presses a small run of cassette tapes, sends them out, and within a year, his song is getting played on local radio. That was just impossible on an 8-bit machine. The 68,000 gave a kid in his bedroom the capability of a major record label.
And then there's just basic usability. The first click.
The Macintosh. When that shipped, families felt like they were stepping into a new world. They weren't typing obscure commands. They were using windows, icons, menus. The 68,000's power is what made that graphical user interface, the GUI, possible. It had the muscle to redraw the screen instantly.
It made the computer friendly. It stopped being a math machine and started being an appliance.
And because so many companies use the same chip, you had this massive shared ecosystem. Developers could write code once and port it easily between the Amiga, the Atari, the Mac. It just accelerated the whole industry.
So the 68,000 lays the foundation, it builds the house. But as we get into the late 80s, early 90s, we needed an upgrade.
We needed a second story, yeah. Enter the 32-bit generation, the shift from the original 68,000 to the 68030 and beyond.
There's an analogy in the notes here that I love. It says moving from the 16-bit 68,000 to the 32-bit 6830 was like upgrading from a modest family sedan to a roomy minivan with a powerful engine.
It's a great comparison.
Yeah.
You still have the same driver. The software largely works the same way, but suddenly you have so much more room and power. The 68030, which came out around '87, added a few key things. But the killer feature wasn't just raw speed. It was the MMU.
The memory management unit, this sounds boring, but I have a feeling it's the secret sauce.
It is the secret sauce of modern computing. Without an MMU, programs are like toddlers in a sandbox. They throw sand everywhere, they bump into each other, and eventually one hits the other with a shovel and the whole thing comes crashing down.
That's the guru meditation error on the Amiga or the bomb icon on the Mac, the system crash.
Exactly. One bad program takes down the whole machine because it accidentally wrote over memory the operating system was using. The MMU is the playground supervisor. It draws a chalk circle around every program and says, this is your memory. You do not touch anything outside this circle.
So if my word processor crashes?
The supervisor sees it, shuts down just that one circle, and your music player in the background keeps on playing. It brought stability. It allowed for true, protected multitasking, which is what turned these machines from gaming consoles into reliable workstations.
And this reliability paved the way for some heavy hitters. The Amiga 1200, the Atari Falcon 030, the Mac II series.
And we absolutely have to talk about the NXT computer.
The Black Cube, Steve Jobs' masterpiece after he was kicked out of Apple.
Right. Commercially, it was a bit of a flop, but historically, it is pivotal. There was a specific NXT cube sitting on a desk at CERN in Switzerland. And because that machine used the Motorola 68030 architecture, because it had that flat memory, that stability we just talked about, it was the perfect machine for a project a guy named Tim Berners-Lee was working on.
Wait, you're talking about the World Wide Web.
The very first web browser and the very first web server were written on that NXT machine.
That is wild. The entire digital reality we live in today, the fact that you are streaming this right now, traces its lineage back to code written on a Motorola chip in a black cube in Switzerland.
I mean, think about it. If he'd been given a standard PC with a segmented Intel chip, the web might have looked very different or could have been delayed by years. The ease of programming on the 68000 family literally facilitated the invention of the modern internet.
I never made that connection. And this 32-bit power also kicked off a multimedia explosion, right?
Oh, absolutely. Suddenly, full-screen video playback was possible. Multi-track digital audio recording without buying thousands of dollars of external gear. Early 3D graphics.
This is where it gets really interesting for me, the stories of people using this stuff. The anecdotes get even more professional in the 32-bit era. There's a story about a teen in Germany in 1993.
Yes, using an Atari Falcon 030. Now, the Falcon was special. It had a DSP, a digital signal processor, built in. This kid used it to record a full band in his parents' garage. The quality was so high that the demo tape actually landed them a contract with an indie label.
From a garage to a record deal, powered by a home computer.
And then there's the publishing boom. A small publishing house in Portland used a Macintosh to design and print a local magazine. Because they could do the high-res page layout in-house, they saved a fortune. Within 2 years, they were in national circulation.
That's the democratization we talked about. It leveled the playing field.
It really did.
Yep.
And gaming, of course. By 1994, we're seeing early 3D. We have an anecdote about friends gathered around an Amiga 1200 playing Descent.
Oh, Descent, the game where you fly through tunnels in full 3D.
That's the one, wireframe tunnels, full 360-degree movement. It was mind-blowing. It actually gave people motion sickness because they weren't used to that level of immersion. The source says that game inspired a group of them to go on and study computer graphics in university.
It literally sparked a career.
And that's a key point. Universities adopted these machines, Macs, Amigas, to teach C and assembly language. This hardware trained the entire generation of engineers who went on to build the dot-com boom.
It's amazing to trace that lineage. So sadly, the 68000 era did come to an end as the main desktop CPU. But where are they now?
Well, the DNA lives on. There's a descendant line called Coldfire that's still used today in embedded controllers, industrial equipment, medical devices, that sort of thing.
And I know people are still using the original hardware.
Oh, absolutely. The retro computing community is huge. People are restoring old Amigas, building new hardware.
Yeah.
There's a project called the Vampire Accelerator that basically recreates a super fast 680-A60. They are keeping the platform alive.
That is some serious dedication. But even if you aren't restoring an old beige box, this legacy touches you, doesn't it?
It does. I mean, if we sum up the impact, the 68000 family proved that a personal computer could be a workstation. It made professional-grade tools affordable.
And the design philosophy itself.
That's the real legacy. The concept of a clean RISC-like instruction set, that directly inspired the ARM architecture.
ARM as in the chip that's in my phone right now.
Exactly. The chip in almost every smartphone on the planet. The designers of ARM were heavily influenced by the elegance of the 68000 and concepts like virtual memory. That was made possible by the 68030's MMU, and now it's standard in everything. Windows, Mac OS, Android, everything.
So what does this all mean for the listener today?
It means we're standing on the shoulders of giants. We often think of technology as disposable. You know, last year's phone is trash. But there's this continuous thread.
I love that.
So every time you click an icon, every time you edit a photo on your phone or compose a song, you are relying on a digital lineage. And that lineage traces directly back to this pioneering 16 and 32-bit brain that first had the audacity to bring workstation power into the living room.
It's a reminder that the sleek devices we have now didn't just appear out of nowhere. They evolved from these beige boxes, these happy Macs, and these brilliant chips.
And the desire to create, to make music, to publish, to code was the driving force that pushed that hardware forward.
A perfect place to leave it. Thank you for taking this journey back to the Silicon Revolution with us. It's been a real deep dive.
My pleasure. It's always good to look back to see how far we've come.
And to you listening, next time you swipe, tap, or click, just remember the 68000 will catch you on the next deep dive. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.